How's everybody doing today? I am still, hi there, thank you, go ahead. But can I request another round of applause for you, Greece? This has been a really wonderful time. I love your city and your country and your culture. I'm excited to go back and tell Microsoft about you. It's awesome. I'm going to be talking about making stuff. I'm the same Jeremy Foster from yesterday, so I won't spend any more time on that. But I do once again invite you to find me online. I'd love to engage with you. I love talking with the public, whether it's to your company or to you personally. Just trying to grok technology, trying to learn, trying to advance in this stuff. And this topic is quite a bit different from yesterday. Yesterday I was talking about Angular, a very specific framework inside of client development, inside of one section of the software programming world. And today is more of some big ideas, some trends, some concepts. It's going to be kind of fun. I'm talking about making stuff, and I'm talking about the fact that we are at the forefront right now of what's at least informally called a maker movement. Have you guys heard the maker movement term in Greece? Anyone? It's a big thing in the States. The de facto community for the maker movement is Make Magazine and Maker Fairs. And Maker Fairs are popping up all over the world. And so people are talking about this maker movement, and it's a really exciting thing for me because when I first went to school, I had the option of choosing my degree like we all do, and I got a little bit of information about what computer science entails and about what computer or electronics engineering entails, and I discovered that there's a degree program, at least in the States, called computer engineering that's kind of a mixture of the software side and the hardware side, and I thought, this is where I want to be, this kind of middle ground where there's hardware and there's software and it's working together. And that's what I went to school for, is computer engineering. And then I spent most of my career in software. I did a lot of web development and a lot of front end and database and some back end. And then this maker movement started happening and IoT became a thing. I mean, the concept was there in the first place, but we got the three letters, IoT, and all of a sudden it was a thing. And when that started hitting, I was like, oh man, this is exciting again, because I get to go back and find my little electronics kit that has resistors in it, and I get to play with electronics again. And it's a whole lot bigger than just that. It's not just electronic components and software, it's more. And that's what we're going to be talking about today. We're going to be talking about this maker movement, the fact that these communities are spreading around the world and popping up all over the place, and people are making some pretty cool stuff. And I'm going to argue today that this is in us all. This is something that we all have in common. It's not just a few quirky individuals. There are some brave individuals that spend a lot of time on something that they want to make, and then they put it forth and they bring it to the maker fairs. But this is happening in all of us all the time. This is nothing that you don't know. If you have kids, you have these all over the floor and you step on them. My son is way into Legos. He didn't build that. This is a picture from online. But you see this happening across the world, across generation, across gender. Everybody makes. It's a concept that is in us all. In fact, when you look back at your history, and that's one of the wonderful things about being here in Europe, in America, I was talking with somebody, we have a rich, 300-year history. So we go way back, 300 years. It's crazy. And I'm from a little area in the United States that goes way back, maybe 80 years. It's just, ancient history. And so it spans all of these spectrums, and that's pretty exciting. This is a project that I worked on. This is a radio that I made from scratch, and so I made an online video about it. It was a really fun project. I followed a guide online, and the only real component in here, the only silicone in here is one diode. And the rest of it is just wires and wood and aluminum foil. And I was able to wire this thing up, and then these pieces of aluminum are separated by a piece of paper. Does anybody know what kind of a component that becomes? It becomes a capacitor, and you can slide it up and down and vary the capacitance, and that's how a radio works. And I did this, and it worked. I got my local radio station, and I was like, ha ha ha! This is so cool. This is so awesome. And you have that moment all the time. Raise your hand if you were in my workshop 2 days ago. Did you turn the LED on and go, ha ha ha, this is so cool, I just lit up an LED? Like, yeah, that's what it was made for, but still, I just did it. I lit it up. And then when you plug it into the Raspberry Pi and you write some code and you turn on the LED, it's even a bigger thrill. Once again, if you have kids, you, like me, have an excuse to play Minecraft, right? Because you have somebody to blame it on. It was my son. He was playing Minecraft. He was playing way too much Minecraft last night. But my son is 5 years old, and he didn't build this once again, but my son is 5 years old, and he's building all kinds of stuff on Minecraft. He even uses the redstone powder, and he's building circuits. This is like geek dad seeing his son learning about AND gates at 5 years old. I am thrilled. Like, I didn't learn about AND gates until college. So this is awesome. People are making things. I love this table. Somebody actually cut out all these layers using topographical information, and when they put it all together, it looks like a topographical aquatic scene here, where the layers of blue look like they relay the depth of the water as well. I wish I had time and materials and machines to make that. That's pretty awesome. Who thinks of this? And where are you when you come up with this idea? I know this was a shower thought for somebody like, oh, I could put these three things together and I could make this crazy little useless contraption, but that will go viral on internet. That's pretty cool. Have you seen the useless box? It's useless. Have you seen this one? It's even more useless. It's like useless times 10. Why don't you... I like to say nope, 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 nope. That's absolutely awesome. This is using a Kinect that's mounted looking down, and so now we're starting to get into some intelligent things. We're adding some smarts to our systems. This is looking at the depth information of the stacked sand and then projecting topography and color on top of that. And you start to go, oh man, this is awesome. You start to see how when you combine material design and electronics and software and the cloud, you could do some amazing things. You can open up some new paradigms. Look at this robot. I've never made anything this cool. This guy's riding a bike. And then he even has this move at the end where he's like, yo. I've never made anything that cool. And then these ones will either inspire you or terrify you. This is a fleet of drones that have some swarm algorithm that allow them to, in a peer-to-peer fashion, coordinate their movements with each other. Yeah, that's a little bit freaky. Watch these guys go through the window. We're all doomed. And then look at this one. This is a TED Talk. I beg you to go look this up because I'm only going to show you one short clip of it, but I have to preface this one a little bit. These drones actually have software on them. They have really good positioning systems, you may notice, so they know exactly where they are. And then they have software that's modeling their own physics and the physics in the system around them. And what they're going to do here is these three drones are going to work together to notice when this guy throws a ball. They're going to calculate the trajectory, and they're going to go catch the ball in a coordinated effort. And as if that's not enough, they're then going to calculate the reverse trajectory, and they're going to throw it back directly to where the ball came from. So let's watch this and be amazed. If you know a little bit of software, you know how big of a feat that is to make that happen. But when this guy talks about it, he talks about how the software is not very complicated because it's more a matter of replicating the model. Notice when these things actually snap, when they actually throw the ball back to him, at one point in time, they are vertical in the air. And then they come back down, and they all three have to recover from that. It's because they have a good model, a physics model, of what's around them, and they're able to use that to adapt. It's pretty fascinating. And the point that I'm going to make today is that you are a maker. You know how you talk about like music and you go, I'm not musical, I can't sing, or somebody brings up drawing and somebody says, I can't draw, I couldn't draw anything, you know, I'm not an artist, I'm not artistic, I'm not creative. Malarkey, that's an English term, malarkey, maybe you haven't heard it. It means no way. That's not the way it works. Like, there are skills that you haven't developed yet, but if you go down to a lower level, we are all people who need to create, who are designed to create. It is in us to create. You know what creation actually is it's organization. When we're software developers, we're organizing ones and zeros. We're putting them in an order that has meaning. It does something, right? It gets business done. It educates people. It inspires people. We're organizing bits for a reason. The guy that likes to work on his car, or the guy that likes to do whatever kind of creation you can think of, what we're actually doing is we are organizing materials and organizing electronics and organizing bits. And we are fulfilling this role that we all have as makers. It's true, your dad was a maker and your grandpa was a maker. So what's the difference now? Like, what is it that we have now as makers, as modern makers, that my grandpa didn't have as a maker? And here it is. We have t-shirts that say maker. So there you go. If you've got the shirt, that's your identity, right? You are a maker. But no, really, we have more technology in the tools that we're using. We have tools that are really, really cool, and I'm going to show you a few of those tools in just a second. We also have tools that are more affordable. It's not something that you can only buy if you have a factory. It's something that you can buy and put in a community maker space, and you could actually get some time on the machine. Remember, in the early days of computers, it was all timeshare, and now we've got them in our pocket. Who knows what the world of maker tools looks like 20 years from now, but right now we have access to some of these tools at some shared spaces, and that's pretty exciting. We also have platforms for learning and for showcasing our expressions, our creativity, the things that we make, our creations. And that's really important to be able to showcase that. That's another human component. So the fact that we have the t-shirt, though, that's perhaps the most important part. That's really what makes us that. So why is this maker movement such a big deal? I think that there are a number of advantages, but fundamentally there's less time and distance between your idea and the product. I heard somebody say what we're trying to do is we're trying to get from duct tape to Best Buy. It's a big electronics store in the US. Duct tape to Best Buy. We're trying to get from that prototype that you build on your desk and it works and you go, it works. I just got it to work. You're trying to get from that to actually having something that you can deliver to the world. That's what we want in this. We have less wasted material. So whenever you build something, like for instance, this is the resin for a resin printer, and I send my design, I make a little widget in my software, and I send it to my printer, and it tells me, excuse me, it tells me this is going to use 240 milliliters of resin. And I know exactly how much my resin costs, and I'm not going to use 241 milliliters. I'm going to use exactly 240 milliliters. And that's pretty amazing when you compare it to some classic techniques, some classic construction techniques that use far more than that. Excuse me, I'm going to get some water here. Unless you're me, and then there's not a lot of waste, because when you make things, they oftentimes turn out like this or like this. So eventually it will be less waste. Ideally and theoretically it's less waste. There's that proposed feature. There's also less transportation. Imagine you want something to comb your hair. Currently, this is something that you can find. You know, you can find these combs, right? We've already got a model for that. But where do they come from? Probably halfway around the world is where they're actually created. And how much of the cost of that comb do you suppose is transportation versus actual manufacturing? Well, what if the things that we wanted to use were created closer to the place that they were consumed? They were created closer to where we actually used them, and we cut out transportation altogether. Do you suppose we would all of a sudden have double-digit productivity gains if we were able to create those things closer to? And instead of having to buy these in bulk, instead of having to buy 100,000, we could just make one. That's all we need right now. And when it breaks, we can make a new one, right? Now, I want to talk a bit about communities that arise in the maker space. I already told you about Make. Make is a very popular community. These are popping up all over the place. They're really exciting. I went to the one in New York, and I went to the one in San Francisco. We have what's called a mini maker fair in Seattle. We're not legit yet. We're just a little town. But I looked it up, and actually, you have a mini maker fair here in Larissa. Did anybody go? It was just a month ago. Was anybody there? Not one. Did anybody know about it? Raise your hand if you knew about the Mini Maker Fair in Larissa. 3 people. Light bulbs just went on. Now you know, next October time frame, there's going to be a Mini Maker Fair, a 2-hour drive from you. So I want you all to go to that. You will be inspired, okay? There are some really, really neat things at these maker fairs. There's also some meaningless things, like this guy who put lobsters on his car. I don't know. But then there's some meaningful things too, like this group of folks, Makers for Good, who their whole charter is to use their maker skills to do things to help the greater good. I think that's really awesome. And I'm going to talk a little bit later about some people that use their maker skills to do some cool things for good. But these communities are popping up in various places that are maker spaces that have all kinds of tooling. They've got a big, expensive laser cutter, and they've got a big, expensive 3D printer, and they've got classic woodworking tools. And you can get little slices of time to learn how to do all of this and also to make your product. You just bring your materials. You bring a piece of plywood, you go home with a chair. You bring your raw plastic, you go home with a new plastic gadget, whatever it is that you need. Microsoft actually has a makerspace in Building 27 on campus. It's called the Microsoft Garage, and a lot of cool things come out of the garage. They ask us as employees to just come in and make whatever we want. We can take it home. So last year for Christmas, I made little hangers for my stockings on the 3D printers in the makerspace, and I brought those home, and they worked perfect. They fit exactly right. So it's pretty neat. These guys are working on another product, a pretty cool little I don't know what it is. It's a Xbox dance machine or something, but they're working on that in the garage, so that's pretty nifty. Athens has a makerspace, and I know that's a long ways from you, but I also found that there's a student group in Thessaloniki that's trying to, Thessaloniki, I keep saying that wrong, Thessaloniki that's trying to put together a makerspace here. So if you guys have any way of helping to make this happen, you could get one of these shared maker spaces right in town. It doesn't have to run like a classic business. In Seattle, we have a few maker spaces, and some of them have actually gone out of business because it's a difficult business to run. It's difficult to make it work, but there's one that's going really well, and it's because it's all volunteer-led. Entirely volunteer-led, and they've got some really good leadership. They're doing a great job, lots of classes, and people are going there learning, and it's really wonderful. So let's talk about some general techniques for making things. Now, at the highest level, we have the ability to make things by putting things together and doing additive manufacturing, and we also can take things away and do subtractive manufacturing. It might look something like this, where you use a 3D printer to build up from raw materials, or it might look like this, where you take some sort of a stock and you carve it down to the final product. You do end up with waste when you do subtractive manufacturing like that. There's a few techniques, a few fundamental techniques to manufacturing, and I just pulled these off of Wikipedia, so feel free to go read about these techniques. It's not like it's a gigantic world of difficult things to learn. There's a lot of processes, but you could spend a little bit of time online and learn a lot about casting and molding and forming and machining and joining and all of these different strategies. And a lot of these, there are some really good videos for how to do just that at home using say a 5-gallon bucket and a 2x4. It's pretty creative. But let's look at some tools. And we're going to first look at some classics, things that you absolutely have to have, like a hammer and a glue gun, and you have to have some Band-Aids. You've got to have the basics for sure, but then you're going to need to get access to some other tools. And don't overlook the sewing machine. This has been around for a long time, so it's not novel, but it sure is exciting what you can do with a modern sewing machine. We got vinyl cutters, so we can cut things out of vinyl and do imaging, that manufacturing technique of imaging by cutting things out of vinyl and putting them together. A lot of pretty neat things that you can do there because you can design whatever whatever you want in 2D, send it to the vinyl cutter, and now it exists as something that you can stick onto a wall or whatever. We've all seen 3D printers, and there's just way too many to choose from. We have 3D printers that fit on our desk and those that definitely wouldn't, but it's a big world, 3D printers. The classic ones use extrusion. Essentially, there's a plastic material that goes through a heated nozzle. It melts the plastic and it deposits it in a certain shape on the bed. This is a pretty great technology. It's difficult sometimes to get that plastic to lay down just right, and there's other techniques to do 3D printing. One of them is using resin. It still uses layers and creates this out of plastic, but it does it by using a resin that hardens whenever you shine UV light on it. So it uses a UV laser underneath. You actually don't get to see the laser. It's underneath that tray, and the build plate comes down from the top, and it builds your part upside down. So you still see the build plate come down, and then you see your part emerging from the liquid goo. It's really cool. It makes you feel like a Greek god. This is the form printer, and there's a Netflix documentary about this one that's really great. You might want to go watch that. There's also, has anybody seen or heard of the Carbon? It's the same concept as the form, but they have a pretty amazing technology in there. It's a very simple thing. It's a permeable membrane that allows oxygen to come through the tray, and that allows them to go way, way faster. This is sped up actually 7 times, but you can actually, at 7x, you can see this thing coming out of the goo. You can see your part coming out of absolutely nothing at all, and it's just like, what is happening here? I designed something, and now it's real. Absolutely awesome. There's a lot of other machines too. This is a desktop mill. So, we've got giant CNC machines. We've had them for a long time, and you can build all kinds of great things. But if you just want to build little things, etch circuits and design little wooden statuettes or whatever, the other mill is a popular desktop mill that you can send your 3D design to. It'll use a tool, and it'll cut it out. Pretty great. There's also a popular desktop laser cutter called Glowforge, and this is maybe larger than it looks, but you put a piece of stock in here, maybe acrylic, maybe wood. You send your 2D design to it, and this actuates a laser and cuts out or etches your pattern on the surface of the material. And it's totally something that people can feasibly put into a makerspace, or if you've got the resources, actually get one for home. Here's a laser cutter working. And once again, this does cutting and imaging, so you can also etch right onto the surface of something. And what she's doing is making something composite out of this, out of cardboard. I have a son named Jack, and my wife asked me if I could make something that we could put this mattress in that he could sleep in. And so I made something. I ended up calling it the Jack in the Box. And it was too large for the laser cutter that we have at the Microsoft garage, so I made it in 2 pieces, and I just designed these little puzzle shapes into it so that after I printed, I just slid it together, and they fit perfect, and it was completely interlocked. It was really fun to do. The Wazer, we now have a desktop water jet. So water jets have been around for quite a while, but a water jet, this is basically think about it like a fire engine pump attached to a hypodermic needle with some abrasive in the water that's able to cut through all kinds of materials, even titanium. There are water jets that are all the way from this size all the way up to gigantic water jets that are, they would take up the entire room. And so that's pretty fascinating when you think about being able to cut out very, very fine detail without the burn lines and stuff of a laser cutter. Of course, you have to make sure that it's okay if your part gets wet. This is a cool tool called the Shaper Origin that just kind of blew my mind when I started looking into it. This is kind of like a router, but it's a smart router with an imaging system such that you lay out some tape that orients the machine on the part, and then you pass your design to it digitally, and then it's able to virtually lay that out on the stock. And then as you follow these lines generally, you'll notice that you don't have to stay right on it. It uses some motors in there to move around and make sure that it cuts the part out exactly. There's also something similar called the, just blanked on the name, it's called the Goliath or something like that. And this one is, the Goliath, thank you. And the Goliath is a similar thing, but it runs around on its own. So then you can go get coffee, and you come back and you have a chair. That's the way that works. And then this one is my favorite. I love this one because this one is attainable. This one is something that you can order for like $300 US. It comes in a box, and you go get some wood and you put it together yourself. This is called the Maslow. And with the Maslow, it's like a drawbot. You basically put your own router in it and build this little sled and then hang it on the stock, and it runs around and cuts your part out from the stock. So what this one's working on right now is a full chair in multiple pieces, and all of that can be done for an attainable price. Now, I was seeing all of these maker tools that were coming out, and I was like, that's awesome, that's awesome, that's awesome. But at one point, I realized, as far as the size goes, as far as the dimensions of what these can build, there's not really a limit. I mean, these that can run around on a flat surface and cut something out, you can just let that go. You could let that go all the way across the room and etch your floor, or cut something out that's gigantic, right? 3D printers, what's the end of scale for that? Who knows? Who knows how big they can be? This is the world's largest 3D printer in a short time lapse of actually making something out with a traditional extrusion technique, something that's large and plastic. That's pretty great, but look at this guy. This guy has a concrete 3D printer, and he's building a play castle in his backyard for his kids. Talk about somebody who has too much time on their hands. Can you imagine being able to print a house? In fact, China was able to print 10 houses in one day using a very similar technique. And then this company is actually using this technique to print a bunch of little villages, basically print an entire village in Italy for impoverished people that don't have the funds to build houses. And in an afternoon, they can build an entire village. And I just think that's absolutely wonderful. Now, all of these things either make something that's 2D or they make something that's 3D. They may make it out of one material, or they may make it out of a bunch of materials. But at the start, you have to design it. That's an absolute necessity. And when I started seeing these things happening at scale, I realized that this is one of those cross-cutting skill sets, those skills that you can't afford not to have. Certainly not as somebody who attains to makerhood. Certainly not as if you're a software developer. But even just as a human, I feel like as a human, I want to have the skill of making things in 3D. So I went to learn the skill of 3D design. I spent a bunch of time in SketchUp, and I kind of ran into some limitations, and it was kind of frustrating. And I went and I eventually found Fusion 360. And Fusion 360 is a program that I really fell in love with. It's really awesome, and I'm going to give you a short demo right now. But this is where you bring your concepts to life. You kind of software prototype them. You can do simulations. You can do animations where you can have an engine that actually operates. I created a little tray that I can attach to a drone, and it can drop candy from above a crowd. And I was able to illustrate that by animating that before I ever printed it, before I ever brought it to life. Really, whenever you're making things, there are these 4 different pieces of the process. There's the material design and material build. And then you put some electronics in it, and you make it smart, right? Remember the robot riding the bike? It doesn't necessarily need the cloud, but it needs to have some electronics. It's like a really fancy gadget. And then to make it smart, to give it the ability to have a feedback system, you need some software. So you add software to it. And then to really light it up as an Internet of Things object, you hook it up to the cloud so that you can communicate with not only all of the features of the cloud, more compute, more data storage, more of all of that, but also so that it can communicate with other things and you can get something done. So those are the 4 steps that I keep in mind whenever I'm making things. And so now let's take a quick look at making something in Fusion 360. Let's just say that I want to make a little cam gear, and so I open up Fusion 360, and I say, I'm going to start with a sketch, and that sketch is going to occur on the fundamental plane here. So, create my sketch. Why isn't it bringing up my plane? What's that? You can't see that? That's PowerPoint's fault. PowerPoint stole my view settings. I'll just blame PowerPoint. There we go. Now you can see it, right? Thank you. Thank me. Thank All of us. Okay, so now I'm going to create a sketch. Yeah, no, there's nothing exists yet. It's blank. That's the way it always starts. Yeah, I have the grid turned off. Okay, so, but I actually, whenever I create something, like whenever you create something in 3D, you oftentimes start in 2D, and now I'm starting to agree with you that there is something weird. Because I don't see my origin. Let's just try this again. That's what I always do when it doesn't work. I used to do tech support on the phone. It works every time. Did you restart it? Every time. Is it plugged in? And actually, technically, no, it's not. Let's give this a shot. Launching Fusion 360 sometimes can take a while. Fusion 360 is kind of a futuristic CAD software program. The folks at Autodesk invited me to be on the advisors board for the software, and so I spend a lot of time with it and with them, trying to help kind of shape its future. And the company itself is really excited about it, because you know they have a lot of CAD software that already exists, a lot of popular CAD software that already exists, but they see this as like the future of 3D design. Almost supplanting really powerful tools like Inventor and AutoCAD. The features of Fusion 360 are becoming more and more robust, and yet it's something that you can actually start to learn relatively quickly. It's got some good user paradigms in it. So let's try this again. That works much better. I say I want to create a sketch, and I'm going to start on this plane. And so it's going to take me to a view of that plane and allow me to create, let's go ahead and start with a circle. Remember, this is going to be a cam, so it's going to be like an egg shape almost. I'm going to start with this circle, and I'm going to make a circle that's nearby that's a bit smaller. Okay, now I can just lay that out and say it looks right, but I need the measurements to be exact. So I need to create some constraints and some dimensions in here. And in fact, if I look at this circle, I already have a constraint on it that it's a certain diameter. But I can go in more explicitly and say, I want this to be 100 meters in diameter. So there it is. And I know that based on my spec, this should actually be 50 millimeters in diameter because it has to be exactly the same size as this one. Well, if it has to be exactly the same size as this one, then instead of even saying 50, I'm going to go get a reference to this one. This one's called D1. And over here, I'm going to say, I want this to be D1 divided by 2. And there it is, half. And now whenever I find out that my spec has changed, and this is actually supposed to be 90, both of my circles are changed. And now I can create a line, and I can join these to create the shape that I'm looking for. And notice that I get a little X on the screen. That means that I'm going to create a line that's coincident to it. But when I get over here, if I get in just the right spot, that turns into a tangent glyph. And now I've created a line that's exactly tangent to this circle. And then I can also click on this line and this circle. And I can say that I'm looking to create a constraint. I want those to be tangent. And now it puts that constraint in force, and actually this is a big solving system that makes sure that those stay in force. So let's do one more line. We almost have the shape that we want, so I'll start with that, make sure that it's tangent, and then I'll click on tangency here on this line and this circle, and that's exactly the shape that I want. Now I can grab these profiles, this profile here, this circle, and the small circle and the space in between, and I can turn that into a 3D object. And instead of just raising it up again visually, I know that this is supposed to be 12 millimeters thick, and so I just created a 12 millimeter object that has exactly the dimensions that I need. I can bring that to life with a 3D print. I can make sure I marry it up with a part that I'm trying to maybe screw it into or adhere it to, and I have the exact piece that I want. So I always start here, even if it's just for visualization and prototyping and whatever, and then I go and I make things, and I hope that you guys do too. And now I have just about maybe 8 minutes remaining, and I'm glad to take any questions that you guys have.
Anybody have any questions? By the way, Fusion 360 is free for makers, so if you want to use it, you can just download it and use it for free. Anybody have any questions? Come on, you have to have a lot of questions. It's mandatory. Nobody? All right. Well,
there you go.
Yeah, do you want
Thank you, everybody.
Thank you very much. Thank you, Jeremy.